I'm going to share my screen. So everybody should be seeing my pie chart right now and my Chrome. So tonight we're talking about functions. Functions are wonderful things because last week in looping we started to discuss reusability and writing your code to be data-driven. So you could have a block of code, you would run through the loop with that block of code, and it didn't matter what was happening as long as your block of code could handle the data that was coming through it. Functions are somewhat similar, except they're a way to name a block of code and to pass in the data. So that's what a function is. It says a named series of statements, and that's what it is. Just like you give a variable a name, and that variable holds a value, you give a function a name, and that function holds a series of statements. And that series of statements can be called using that name, just like when you pass around a variable by its name, or you pass around a function by its name. And it's very handy. It reduces the amount of code you have to write. And that's a big thing when you're programming because code is expensive to write. It's expensive to maintain. So when you reduce the number of lines of code that you have to write, then you reduce the cost. And that's important. And it's easier to have higher quality code when you have fewer lines, partly because it takes less time. Well, not necessarily it takes less time, but it takes less time to maintain. And so that's why this is important. So there are a few things to look at when you define a function. And they are the definition itself and then the function call. So if I'm looking here, I'm going to make my screen a little bigger. I have def. Def is a keyword. It means I'm defining a function. That's what the word def is all about. So everything that is right justified under the word def, D-E-F, is going to be part of the function until something is not right justified under the function. So def is the key word. The next thing after def is a name. The name can be whatever you want as long as it doesn't begin with a number and doesn't have any strange characters. It follows the same naming conventions as like variable names do, or very close. Then you're going to have an open parenthesis, potentially some things after, but we'll get to that, and a closed parenthesis. And then, as always, our colon. So that line of code, def print pizza area, open parenthesis, closed parenthesis, colon, makes up what defines a function name. Okay? You have to have all of that on that one line, or you won't have defined a function. Now the name of the function is print pizza area. And everything underneath print pizza area is part of the function. It is inside the code block of the function print pizza area. So when you call print pizza area, it's going to do all of these lines of code. It's going to do all of these lines of code. And when it's done, it's going to stop doing all of those lines of code. So that's the definition of a function. Now, for calling a function, this line down here is how you call the function. You use the name of the function. You'll notice there's no def, there's no DEF. The name of the function is, in this case, left justified. and it has an open and closed parenthesis, just like it does up here, but there is no colon. So that print pizza area, open parenthesis, closed parenthesis, is the function call. And what I'll show you in PyCharm is what happens when that function call. We're actually going to debug and step through the code. And you'll notice in this example that the function definition, the function itself, is before the function call. And it has to be that way in Python. Unlike other languages, like if you've done Java, you can define the function from anywhere, just about, and then you can get to it later. But because Python runs through an interpreter, it has to know about the function before you actually have a line of code that calls it. So that's an important thing. So let's do this. I'm going to do this challenge activity, basic function callout, and we'll go through this in PyCharm. So I'm going to do a new file. And what challenge is this? It's challenge 5.1.1. And by the way, if I'm going too slow, or if there's a lab or some piece of information that you want to get to tonight, let me know so that I can make sure we get to it before we end this lecture. 5.1.1. So this is just the basic function call. So what they've done is they've said def print pattern. Okay, so I'm just going to copy that real quick. I'm going to have it tell me that there's no interpreter. I have to figure out one day how to set that up. Okay, so let's set up the interpreter, and then we'll be fine. Okay, and so what they're asking to do here is they're basically saying, call print pattern twice to print 10 characters example output. So let's take a look at this, and we're just going to do this real simple one quick. So they want it to be called twice. So lines 1 and 2 are the definition and the body of print pattern. Print pattern is a function. We know print pattern is a function because the words print underscore pattern come directly after the keyword def. After print pattern, which is the name of the function, you have an open and closed parenthesis and a colon. So this line number 1 is the function definition. So how do I call print pattern? Well, just like that. I use the name of the function, and I have an open and closed parenthesis. That calls print pattern. And if I want to call it twice, I do that. That's all you have to do. So now I'm going to run this in Debug, just so that we can get an idea of what's happening. So I'm going to set that up on the configuration. Okay, so I'm going to debug this. I have a breakpoint on line 4. So why in the world do I have a breakpoint on line 4? That's because if I had a breakpoint on line 1, it wouldn't stop there to begin with. All Python is going to do is it's going to read line 1 and 2, but it's not going to do anything other than put them in its memory bank because there's nothing for it to do. Nobody has called the function. It is simply a definition. So I am here on line 4. If I step into print pattern, I end up, whoops, I stepped over. Let me start this again. Okay, I get to line 4, I'm going to step into, and now you'll see I go up to line 2. That's because when I stepped into it, I stepped into the function that I created. And all this is going to do is it's going to print that out, print out the 5 stars to the console, and then you're going to see it go back to line 4. And that's because it's just completing the action. So I called the function, it went into the function and did something. Right here you can see those 5 things. Then it came back out of the function. And so when I step over that, I'm going to go to line 5. On line 5, if I step into, it's going to go into the function. It's going to execute the line of the function. And then it's going to be out of the function. And in this case, the program ends. And in my console, I have 2 sets of 5 printed out. So that's the concept of what Python is doing when you're calling a function that you have defined. And actually, any function at all. So we just saw the open and close parentheses. That's it. So when I define a function, the name, at def, the name, open and close. Well, there's a lot of stuff you can put in those inside those parentheses. And that's part of where the power of a function comes from, because that's how you get data from one part of your Python script into the function. You give it a parameter or an argument. A parameter is basically a named input. It's like another variable. That variable will only exist inside that function, and that variable name will be given a value. And it will be given a value when you call the function. Okay? So a parameter is in the definition. And they say an argument is a value provided. So you have an argument in the call and a parameter in the definition. So here you can see their example. We have our print pizza area again. And we have this thing called pizza diameter. Now pizza diameter is a parameter. And I think that was meant to rhyme. I'm not sure. So pizza diameter is in fact a variable. But that variable will only exist, in this case, between lines 2 and 6. You can't use it anyplace else. And you'll notice that it's inside the open and close parentheses. That's because that's where you define a parameter. You only define it inside the open and close parentheses. So nothing about this def pizza area has changed except the parameter. You'll notice also that I can use pizza parameter in here. We've got pizza parameter. I'm getting hungry now even though I had dinner. And then pizza parameter on 3, and then pizza area is the radius times the value, and then you've got your print statement. So here, when we call it, we are now calling it with a value or an argument. So in the case of line 8, we are passing it 12, and 12 becomes pizza diameter. In the case of line 9, we're passing 16, and 16 becomes the value for pizza diameter. So the calculations change based on the diameter of pizza that you're passing in. So let us go down to the challenge for the basic function call. It's output, I'm just going to do this one. It's output minutes as hours, because I want to demonstrate to you what I was just talking about. So, oops, let's do that again. There we go. Okay, so basically what they've done is they're defining a function called minutes as hours. So I'm just going to copy this in here real quick. And let's edit that. Okay. So I need to fill in this function. Oh, first of all, what would happen if I just ran it the way it is? So let me just run this. Nothing. Absolutely nothing happened. Why did nothing happen? Well, nothing happened because there's nothing to do inside the function. That's it. I call output minutes as hours here, and then, but nothing happens, and that's because there's nothing going on inside the function. So what they want us to do is they want to calculate minutes as hours. So I'm going to be passed in minutes, and then we're going to print out what the hours are. So an hour is 60 minutes, so I'm just going to say orig minutes divided by 60. And I'm just going to print just for the fun of it. Okay? So we're taking in an input here of a float for minutes, and then we're passing minutes in. So I'm going to put a breakpoint here, and I am going to, hold on. Okay. I am going to debug this, and on the console, I'm going to start off with 20 minutes. So I'm going to hit the Enter key, and then I'm going to step over. I get to 7. You will see here that minutes is 20, because that's what I put in. And I'm going to step into, now you'll see up here, and this is, I am talking about this through PyCharm because I think it's easier to visualize. So I have orig minutes of 20. So now you see that the value of 20 has been assigned to orig minutes, and it's a float. So I'm going to step over, and it says 0.03333333. So that is the calculation. And I step over again, and I'm done. So I could do this any number of times. So I could, just to add a loop, while and I'm getting you used to loops because you're going to have to do some next week. You're going to have to kind of put things together with loops. So I just wanted to kind of do it as an example. So I have minutes equals 0, while minutes is greater than or equal to 0, 0. We're going to take in minutes and we're going to output. So what I wanted to do here is I want to show you what happens when you're calling this function with just different values. So if I debug it, I'm just going to debug it this time. I'm going to go to the console, and I'm going to say 60. So I've entered 60, and my minutes is 60. I'm going to step into my function, output minutes as hours. You'll see that the minutes is 60, orig minutes is now 60. If I go to my debugger console, you'll see that here. I'm going to print out the value, and then I'm going to keep going. So I'm going to continue on. I'm going to enter 120. I'm going to keep going just to show you that what's happening with orig minutes is that value changes. Whoops, actually, I'm going to put my breakpoint there. So let's do 120. Actually, let's do 180. So I'm going to continue. When I get here, you'll see that orig minutes has now changed to 180. So orig minutes is whatever is being passed in on line 8. So that is what the relationship between a parameter and an argument are, or is, the relationship is. So return values. So we've just figured out how to get information into the function. Now we have to find out how to get information out of the function, because that's just as important. I'm not always just going to put my information out to the console. I might want to get information back that maybe I pass to another function, or maybe I do something else with. I make a decision based on it, which is something you will be doing in your game programming. You're going to call a function, and based on the return value from that function, you're going to move, or you're going to determine whether or not the game is ended. So it's important to understand returns. So we know how to get data in. A return statement is how we get data out. A return statement always has to be the last statement in a function. Period, end of sentence. There can be no statement in a function after the return statement. What does a return statement do? Well, it returns one or some number of values from the function back to the line of code that called it. And that line of code can, as we're doing here, is here's the call to compute square, passing in a value of 7. Now I have this thing in front of that function, and that is a variable. Num squared is a variable. I know it's a variable because it's on the left-hand side of a single equal sign. And to the right is, in fact, a function call. This tells me that, this line tells me that compute square is going to return something. This is a function. It's going to return something. I should expect something back, which tells Python there needs to be a return statement there. And then I can do something with that, the value that's being returned. So for this side of the equation, it's just a variable, and you're just assigning something to a variable. So we've been doing that since week 1. This is the new stuff, okay? And this is the new stuff. But this stuff here is nothing different about it. We'll see some ways to get multiple values out of a function. But for what we're looking at right here and right now, the same thing what we've been doing since week 1. It's a variable, and you're setting a value into a variable. So what do we mean by return? So let me just do this. Let's do a simple return. Okay, so I'm just going to edit the configuration. Yeah, I know it's slow. Okay, so this is just going to describe different kinds of returns. So I'm going to define simple and I'm going to take in val1 and val2. By the way, that's how you set up two different parameters. Just separated by a comma. I now have two parameters. Actually, I'm going to call this area, because that's what I'm going to do. And I'm going to say my area is going to be val1 times val2, and then I'm going to return my area. And then down here, I'm going to call it. I'm going to say area 1 is area 1, 2. I'm going to say area 2 is area 3, 4. And I'm going, whoops. And then I'm going to say area 51 is 50 times 100. There's no meaning to that. Oh, sorry, 50, 100. So what have I done? Whoops, I gotta name it right. Area 50 times 50, 100. So what have I done here? Well, I've defined a function called area, and now I'm going to set three different values to the result of area. So I have one function. I haven't repeated lines 2 and 3 for the calculation of an area, and I am returning something to the calling line. So this return, well, let's go through this and I'll show you. So I'm going to debug this. The first line of code I hit is 5, okay? And so I'm going to step into the function. So I'm going to step into area. You will see that val1 is 1 and val2 is 2, because that's what I said. And one thing I haven't said, let me make this a little bigger, is that parameters and arguments are positional. So val1 is 1 because they're in the same position. Val2 is 2 because they're in the second position. Val1 is the first position as a parameter. The value of 1 is the first argument. So val2 is the second parameter, and the value of 2 on line 5 is the second argument. So they're positional. It doesn't matter how many you have, they are positional. So I'm going to step over, and now my area is 2, and I'm returning area. So when I step over that, we see that there aren't any variables right now, but once I step over line 5 and line 5 becomes completed, you'll see that area 1 is 2. I'm going to now calculate for line 6 with the values of 3 and 4. We'll see that val1 is 3 and val2 is 4. Again, they're positional. And again, I'm not having to change anything in my function, inside my function. Those lines of codes are staying the same. The only thing that's changing is what I'm passing in. So I'm going to calculate my area. I'm returning my area. My area is 12. And so when I return, area 2 is 12. So I'm going to do the same thing for area 51. I am passing in 50 and 100. So val1 is 50, val2 is 100. Again, it's positional. Do I sound like a broken record yet? It's important, though, because when you're programming this for the first time, sometimes people forget things like it's positional, like it's just a variable on the left-hand side. That's all area 1, area 2, and area 51 are. So I repeat myself because when you're talking and when you're lecturing, people only remember 40% of what you say on a good day. So that's why I'm repeating myself. So I'm going to step over. I'm now going to return my area. So the value of area 51 will be, and of course it ended, would be 5,000. And we'll just say print normal area, more normal area, extra, hold up, PT is coming. Area 51. So I'll just run it again so that we can see the completed program. So area 2 is normal, more area is normal, ET is coming 5,000. So I just wanted to put that out there. Yes, I'm a geek. So does anybody have any questions about parameters and arguments? Okay, put something in the chat if you have any questions. Let's see, let's keep going. That's the volume of a pyramid. You'll notice there's this volume of a pyramid thing. So that's very similar to what we just did for area. So when you're dealing with the volume of a pyramid, think about that. Okay. What is the difference between print and return? Okay. Print is a function. Print basically puts something out onto the console. So when I say print here, what print does is this. When I say return, return sends a value back from this block of code to the calling line. So for instance, line 5 is the calling line. So we'll debug this again real quick. So line 5 is calling the area function. So this is the area definition, the function for area. And when I step into this, I do a calculation. Now I hit this return statement. So the return is returning my area, or really what it's returning is the value of my area. So what it's going to return is the value of 2. And so it will then set the value of 2 now to area 1. So I'll see area 1 here. Now notice in the console nothing is on the screen as of yet. Okay? Same thing happens. I get a function call, I calculate the area. I do another function call, I calculate the area. So when I get to the print statement, okay, the only thing that's going to happen with the print statement is I'm going to print that to the console. So that's what the print statement does. It puts something out, it puts text out onto the console. So we're all used to GUIs, you know, we're all used to our iPhones and our computers. Before any of that, there were text interfaces, and that's what this is demonstrating. But print can also be used to print the instructions for your game. Okay, so you're going to have to give instructions to your game. You will want to use a print statement to give those instructions to the user. So dynamic typing. the type of a parameter is not set in Python. The type of almost nothing is set in Python. Python is not a strongly typed language. It is a weakly typed language, which means I don't tell it what the type is for the value that is being passed into a parameter. Okay? The only thing I do is I pass a parameter in. Now, this is a good representation of that, as you have this add, x and y. Well, you think adding is adding. You add two numbers together and you get the result. Well, but we're dealing with a programming language. And sometimes adding in a programming language means that you might potentially have strings instead of numbers. So what happens when you add two strings? But it is completely acceptable in Python from a language perspective to pass two strings into add, just as it's completely acceptable to pass two integers or two floats. I don't have to change the function because I'm passing different types in, because I'm passing a float in, or because I'm passing a Boolean in, or because I'm passing a string in. So that's what they mean by dynamic and static typing, okay? Python's a dynamically typed language. There are very few instances where you're going to have a static type. And if anybody wants me to demonstrate that, I will. So why do we define a function? Well, reusability. That's why they talk about improved readability, and it is. It makes it much more readable. It reduces the lines of code. Reusability is a huge thing in programming. You want as much of your code to be reusable as possible. So that's just more about functions. Stubs. I'm just going to mention function stubs. In incremental development, you might not always want to write your full function all at once. When I'm doing prototypes, I don't always write the code exactly as it's going to be. If I'm doing a prototype, I might stub out a function and put some canned data in there. It's just going to pass back the same thing or a couple different things so I can test the interaction. And then later on, especially if it's a complex function, I'll write all the code. But that's all they're talking about with stubs. I'm not going to worry about that. Branches and loops. You can put anything you've already done up till this point in a function, except for another function definition. You can put a function call in a function. You can put a loop, you can put a for loop, you can put variables, you can put if statements, you can call another function. So you can do anything inside of a function that you have done to date. All right, any of it can go inside of a function. And it's really nice because you can encapsulate that. You can make it its own thing. And then if you have to do it 3 or 4 times, you just call the function. And that's going to be important in one of the challenges, because one of the challenges is kind of long. One of the labs is kind of long. And you can have multiple functions in a program. You can have as many as you want. You have to be careful. You don't want to factor things down too small. You only want just enough functions to do the right job. And I know that's completely vague and makes absolutely no sense until you're doing it. But you want to think about that when you're programming your game. Because that's where a lot of this is leading to. I can sit here and talk about the theory, as you probably can guess, a lot. But what's important for you guys in this class is the fact that you're going to need to use all of this while you're doing and programming your game. So, and I have been trying to bring things back to the fact that you're going to be programming your game. Functions or objects. We really haven't talked about object-oriented programming, but from the perspective of Python, a function is something that's encapsulated because you can pass it around as a thing. It's named. You can pass it around, and we're going to be going more into object-oriented parts of Python, I think in week 8. But for right now, just understand that there is something called an object and that a function is considered an object. It's not really something you guys need to worry about right now. Right now, I think getting the mechanics of functions down is important. So what are some common errors? Well, let's go and look at some common errors. So I'm just going to change simple return. First of all, this is a common error. See how that return statement is on line 3? I've moved it back. So all I did is I backspaced. It was there, now I backspaced. And this is going to give me a problem. It's going to say syntax error, return outside of function. Well, what does it mean? Because the return is the same at the same level, the same column in that file, in the Python file, as the def means that it is not inside the function, it is outside the function. That, because these two line up, they're both left justified, the return is outside the function, and you cannot have a return outside of a function. It's that simple. So when I put it back there and I run it, everything's fine. So now here's another common one, okay? Now I'm going to back up my area. So if I try and run this, it's going to say indentation error, expected an indent block. Well, why did it do that? Well, why it did that was because the next thing after a function definition that Python expects is a line of code inside the function. And again, because I backspaced my area and now it is left justified with def, the D in def and the M in my area are left justified, I don't have a block of code anymore. Absolutely don't. And so Python is throwing up its hands and saying, I don't know what to do. It's not what I'm expecting, because what I'm expecting is that. Okay? So those are two very common things, and they're just indentation errors, but they can drive people crazy. The other thing that happens is our friend the colon goes away. So if I try and run this, I get syntax error, invalid syntax. Now this is one of the few times that Python gets it right and tells you exactly where the problem is. The problem is here, and we did not end it correctly with a colon. So those are a few common errors that drive people crazy. Okay, scope. Scope is very important. We talked a little teeny bit about this in the first week, and we talked a little bit about it with loops. But scope becomes very important because there are 3 scopes. There's a global scope, there's the script scope, and then there is the internal scope of like the function. So when you're inside a function block, you are in the scope of the function. So things may not exist outside the function that exist inside the function. So like feet and inches here are not the same as feet and inches here. They're different. There is a global statement that we won't be using. It's not considered great programming practice. But basically what it tells you is it says something outside of the scope of the function can be used inside the scope of the function. So in this case, it's just employee name, because without that, this employee name isn't this employee name. It gets extremely confusing very, very quickly. My suggestion to all new programmers is name your variables different. Name your parameters different than anything, name your variables different than anything, and you won't have a problem with scope. If you find, and part of the problem with scope issues is that they don't have error numbers. Things don't work right. They just don't. Because you'll be getting a value from a scope that you don't expect. So name all of your variables different if you possibly can, because it will help you, especially in the beginning. Namespaces and scope resolution. This is more about scope. I don't really want to talk much about this because you don't really need this for what we're doing. Scope is important. You have the built-in scope, you have the global scope, and you have the local scope. The local scope is like inside a function or inside a loop. The built-in scope is the built-in names that Python has, like print function or range or stir. And the global scope is everything that is on the outside of that function, or that is outside of a function. Arguments. So we talked a little bit about arguments. Can I have everybody mute? Somebody not muted? Who's not muted? Okay. Okay, I think everybody's muted now. Thank you. Let's see, Tyra. Let me see if I can find you. There should be a little button that looks like a microphone. Okay, I'll look and see. Let me see. Yep, I've muted you. You're good. So this is kind of more about no problem. Each time you call a function, a new local variable is created. So that's part of the scope thing. And we kind of looked at that already when we were doing PyCharm, when we looked at things being passed in PyCharm. Keyword arguments and the default parameter. Remember when I said that everything was based on position? That's right most of the time. You can have a default parameter, and they're very handy, and you don't get them in all languages. But I find them to be very handy because sometimes you don't want necessarily people to always have to pass in everything. So an example, so let's do this. Default param. So I'm going to define a function and I'm going to have var1, var2, var3 equals 0. Okay, now that equals 0 is something we haven't seen before. And then I'm going to say result equals var1. Well, let's do this. If var3 is 0, then I'm going to say return var1 times var2 times, and then if not, I'm going to return var1 times var2 times var3. Now, you'll think I just made a liar out of myself because I said return has to be the very last statement in a function, and it can't, and there's nothing else. But I've just got 2 return statements in this function. So what in the world did I just do? What I just did is for Python, and actually almost all programming languages I've worked on, you can have a return statement inside of an if or a loop or something along those lines, because it will never ever hit this other return statement. If I hit, if var3 is 0, I'm going to return that, and I'm going to end the function call. It just will be done. Otherwise, I'm going to hit that statement and this one. So as long as the return statements are mutually exclusive and Python can figure it out, it's okay. So I'm going to do a few things. I'm going to print with 3 params. Oh, I have some questions. Okay. Let's go to chat. I don't need that break statement, Brendan, and I'll show you why in just a moment. First of all, I'm not in a loop, so I wouldn't need a break statement, but I'll show you why I can do what I just did in just a minute. So actually, I'll do it like this. So I'm going to say now this is just going to be, actually, I don't want the word def there. That's just bad programming practice. Params, and I'm just going to call this as 3. I'm going to say, 4, 5, and 6. And I'm going to put a breakpoint here. I'm going to debug this. Whoops, forgot to change that, sorry. Yeah, I know, my computer's a little slow these days. Okay, so I'm going to debug this. And what happened? I did something wrong. Params is not defined. Params. That would be true. This is what happens when you forget to call the function by the same name you just gave it. I called it params here, and it's param up here. So when I change this, that error goes away. So don't be surprised if you get lots of lines. Usually start at the bottom. When you're looking at error messages, I usually start reading from the bottom up. So I said, it says name error, name params is not defined. That's because I had it wrong. So I'm going to debug it again. And now I go into here, and you'll see that I have var1 is 4, var2 is 5, var3 is 6. So this is the first statement is the if statement. So let's ask the question, is var3 equal to 0? Well, the answer to that is no, it's not, which means it's never going to hit line 3. Because it will never hit line 3, it's going to hit line 4, it's going to return, and it's going to print out what I had it print out. So Brandon, that's why. It's because it will never hit line 3 and line 4. They're mutually exclusive. If var3 is 0, it's always going to hit this, and it's going to end. If var3 is not 0, it's going to hit this, and it's going to end. So let's do this. I'm going to do this with 3 parameters, but the last one is going to be 0. And we're going to debug it again. We already came here the first time, so I'm going to step over. I get to the final one, which is var1, var2, and var3, because it never made it to line 3 because of my if statement on line 2. So I'm now going to print this out. So now I have a new one that's 3 parameters, but the last one is a 0. So I have is, yes, exactly right, Brendan. It ends itself when it hits the return statement. So this time, var3 is 0, so it's going to hit the return statement on line 3. Going to step over that, and you'll notice it just stepped right back out. So it never hits line 4. And then it's going to print it. So now, this is where this default comes in. Okay. Okay. You don't need an else statement. You could put an else statement. This would be a valid, that would be completely valid. It's completely right. There's absolutely nothing wrong with it. This else statement on line 4 is okay. And if that makes it easier to read, go ahead and put it there. Because for Python, it doesn't make a difference. It's still an else. So if it's easier, in fact, I'll leave that in. If it's easier for you to read, to understand, hey, there should have been an else there, you don't necessarily want to put an implicit else. If it's hard for you to read, don't put the implicit else, put an explicit else. So we'll just leave that else there. Because you're right, it's probably easier to read. So this example, I'm not going to pass in 3 parameters. I'm going to pass in 2 parameters. And you're like, hey, wait a minute, but you told me that you have to have the same number of arguments as parameters. What are you doing now? So what I'm doing now is I am allowing the default value to come into play. When I was defining this function, I said var3 equals 0. We haven't done that before. We haven't, what is this var3 equals 0? The equal 0 is a default value for var3. And if I don't pass in a 3rd parameter, it's going to assume that var3 is always going to be 0. That's what it does. So on line 13, I won't get an error. It's just going to work. Because I have this equal 0 after that. So if I debug this again, or actually I'm not going to step through those. Hold on. Debug. There we go. So this is the first one. This is the second call into it. So this is going to be the 3rd call. Actually, I apologize. I'm going to stop and do this one more time. I'm going to debug, go over that one, go over that one. So now we're here. Okay, on line 13, we have retval equal param 4, 5. If, and I'll show you that in a second, if I did not have a default value when I got to line 13, I would get an error from Python. But I don't get an error from Python. It allows me to go in, and you will see when I look at these 3 variables that PyCharm is showing me, var3 is equal to 0. var3 is equal to 0 because I have told it. If you don't get 3 parameters, the last one is always going to be 0. var3 will always be 0. And so it acts just as if I had passed in a 0, and it goes to line 3 and comes back out. So now, well, that's great. Let's stop this. What happens if I only want to pass in one parameter? Oh, let's try that. If I only want to pass in one parameter, let's see what happens. I'm just going to run this, okay, and see what happens. I have an error on line 16, and it says error param missing one required positional argument var2. That's because I don't have a default for var2. I don't have an equals a value after var2. So I'm getting an error. Now I could solve this in one of two ways. I could say, let's say the default is 5, or I could add a parameter here. Now the defaults become very useful if you know that there's always something you want to default to. So you're not expecting the external caller to know what the default is. You're giving it the default. Because I added this equal 5, if I run this program again, everything's happy. It runs just fine. So that's what a default value does. So let's see. I know we're going a little bit over. I apologize. Arbitrary argument lists. Our arbitrary argument lists are important, especially when you're dealing with parameters that are coming externally from a program, because that's what those are. And you can what they have here, and the syntax is, you'll see this star args. That just means any number of parameters. So you can pass in this case, you can pass in 3 parameters. You can pass in 10 parameters. The last parameters come in as a list. Now, this is great. I prefer to pass them in. For me, if I'm going to pass something in as a list, I'm going to define it that way. I'm going to give it a variable, and I'm going to treat it as a collection, an explicit collection rather than an implicit collection. But it's always good to know that you have the option of printing a variable, of putting in a variable number of arguments. Let's see. You can have multiple outputs, and this is a unique to Python thing. You can have multiple variables returned from a function. So, this is something you can't do in Java, and I'm just going to use this def params here. I'm going to define another function. Just going to call it multiple ret var1, var2, and I'm going to say temp equals var1, var1 is var. This is just a standard swap. var2, var2 is var1, I know. And then I'm going to return var1 and var2. And that's a standard swap. You can find it anywhere. So if I call, let's see, I'm going to call A, B equals and I'm going to say 1, 2. And then I'm going to print A, and print B. Okay, so I'm passing in 1 and 2. I'm going to swap them. So A should be 2 and B should be 1. So let's see what happens. I'm going to put a break there. Get rid of the break here. I'm going to debug. So I'm here, multiple ret, I'm passing in 1 and 2. So let's see what happens when I step into it. So var1 is 1 and var2 is 2. So I am stepping over. Temp is now var is 1. var1 is now 2. var2, I did that wrong. Oh, I did that wrong. var2 is temp. I didn't swap right. Sorry about that. Let's go back and look. All right, so we're going to step in, and now my swap is going to work. And then, even though I'm passing var1 and var2 out, A will be 2 and B will be 1. So I have, in fact, set the value of 2 variables on one line by using this return statement that simply has a comma. That's all you have. You have return the value, the variable, comma, the next variable. And I could have done this I could have done it for 10 different ones if I wanted to. As long as here I have a place to put them, A and B. So if I don't have a place to put them, just going to come these out for a second. Let's see what happens with this. If I don't have a B, just an A, let's see what happens when I run this. So, oh, I'm fine. Thought I would get an error, but I didn't. So that is multiple return statements. And I bring it up because Python is unique in languages. I don't know of any other language that does that. Now, I'm not as familiar with some of the more obscure languages, but like Java, we can't do that. Okay, I'm not going to worry about doc strings and doc functions. Here are some engineering examples. You can go through those, guys. Swapping variables. I just went through that. Exact change. So this function is very much like, I think in 3, we did an exact change where we used the floor. And so if you look back, I think it was 3. You look back at the lab in 3, what they're asking you to do here is the same thing, but you want to define a function. And by the way, what they're doing now is, now that we have ifs and else and things, is they're saying if name is main, which is just the way of creating a main function in Python. And all a main function is it says don't start anywhere else but right here. So this is the same as the exact change from, I think, week 3. Maybe it was week 2. So go back and look at that. But what you're doing is you're putting that into a function. So all of that code that you did where you used the floor and determined it was 1 dime or 2 dimes and 1/4, all you're doing here is you're going to define a function that's named exact change, and all of that code that you did previously for that lab is going to go into that function. So go back and find that lab. Don't rewrite the exact change thing again, especially if you got it right. And if you didn't quite get it right, go look at the response from the teacher and redo it. But don't rewrite everything. It's the same as the exact change, and all you're doing is you're having user total, which is what was input, okay? And then here, what you need to do is, remember we just talked about multiple return statements? Well, that's what you're doing here. You have multiple return statements. So the number of dollars, comma, so you're going to say return, num dollars, comma, num quarters, num dimes, num nickels, num pennies. So that's the multiple return statement. So when you're doing this lab, don't start from scratch. So does anybody have any questions? Okay, I'm going to call it, and hopefully this stuff will be up early tomorrow, earlier than last week. And for any of my students, please reach out, ask me any questions that you have, and I should have this out tomorrow. Well, this will all be out tomorrow. So I hope everybody has a good night and that the weather is good this weekend because it's getting cold here. I'm going to stop sharing and stop the recording.